Hello students, in this session for B.Sc Chemistry first semester, and the session is 61. Under the general chemistry topic, I am going to talk about stoichiometry, under which let us discuss about concentration terms, that is molality, mole fraction and ppm, and also we'll look into the problems on molality, mole fraction and ppm. Prerequisites, that is concentration of a solution, and moles already we have discussed in the old video. We'll directly pass on to molality, which is denoted by small m, whereas molarity, which is denoted by capital M. It is the number of moles of a solute present in 1 kg or 1000 gram of a solvent. So, in turn, we can write it as m is equal to, small m is equal to number of moles of solute by mass of solvent in kg. So, number of moles of solute is nothing but weight of solute in grams by molar mass into weight of solvent in kg. So, in turn, we can write it as weight of solute in grams by molar mass into 1000 by W gram of solvent, that is weight of solvent. So we'll look into the problem. If 14 gram of ammonia is dissolved in 250 gram of water, then what will be the molality of solution? So we'll write down the equation. M is equal to weight of solute in grams by molar mass into 1000 by W gram of solvent. So weight of solute is given 14 by molar mass of ammonia is nitrogen NH3, that is we get 14 plus 3 into 1, 14 plus 3 is 17 into 1000 divided by 250. So if you calculate, we get molality of this solution is 3.29. Let us pass on to mole fraction, which is denoted by capital X. It is the ratio of number of moles of one component in a solution to the total number of moles in a solution. So, in a solution of solute A dissolved in solvent B, small na stands for number of moles of solute A, and Nb stands for number of moles of solute B. Then mole fraction of solute A is written as XA is equal to Na by Na plus Nb. Similarly, mole fraction of solvent B is given by Xb is equal to Nb by Na plus Nb. Also, XA plus XB is equal to 1. Let us look into the problem. A solution formed by dissolving 8 gram of NaCl in 100 gram of water. Then calculate the mole fraction of NaCl. So we know the formula. Let us write down. X NaCl is equal to N NaCl by N NaCl plus N H2O. So let us know first. Let us write down what is NaCl. So here it is given 8 gram by its molar mass is 58.5, which gives you 0.136. Similarly, for water, that is NH2O is equal to 100 divided by 18, which in turn we get 5.55. Now, let us substitute these values in the formula. In this formula, X NaCl is equal to 0.136 divided by 0.136 plus 5.55. 0.55. So we get X NaCl, that is mole fraction of NaCl in this solution is 0.023. Next we'll pass on to parts per million. That is, in short, we call it as ppm. It is the number of parts by mass of the solute in a million parts by mass of the solution. So it is nothing but ppm is equal to mass of solute divided by mass of solution into 10 to the power 6. Or in a very simplest way, if I am going to define is, it is 1 milligram of solute. If you dissolve in 1 liter of the solution, sorry, here it is solute, 1 milligram of solute, if you dissolve in 1 liter of the solution, you will get 1 ppm solution. We'll look into the problem. If 10.2 gram of carbon dioxide dissolved in 1500 gram of water, then what will be the ppm of this solution? So let us see the ppm of carbon dioxide is equal to, write down the equation, mass of solute divided by mass of solution into 10 to the power 6. So it is mass of solute is given 10.2 divided by mass of solution is 10.2 of carbon dioxide and 1500 gram of water. So into 10 to the power 6, finally we get 6754.0 is the ppm of the carbon dioxide. So summary, so in this concentration terms, molality, mole fraction and ppm we discussed, and also we solved simple problems under molality, mole fraction and ppm of a solution. So the books I referred is Bhal and Bhal and Tuli, GD, by the textbook is Essentials of Physical Chemistry. Principles of Physical Chemistry by Puri, Sharma and Patania. Textbook of Physical Chemistry by Negi AS and Anand SC. So you can refer any physical textbooks containing stoichiometry. This is Digital Learning Department of Collegiate Education is presenting these videos for you. Thank you very much.